The learning target, I can determine whether a number is rational or irrational. So what do you need to know? To determine if a number is rational or irrational, you want to answer the question, can I write this number as a ratio of integers? Or in other words, can I write this number as a fraction? If your answer is yes, it is going to be a rational number. Rational numbers can be written as a fraction, hence that prefix of that word ratio. Ratio means fraction. Any rational number is going to terminate or going to have a repeating decimal. Okay, terminate, that means to end. And repeating, that means it's going to have some sort of pattern. Other examples of rational numbers include perfect squares. So a perfect square is something like 25, square root of 25, or the square root of 16, because when you simplify those, you end up with an actual rational number. Irrational numbers cannot be written as fractions. They are non-terminating, non-repeating decimals. Some examples would be numbers like pi. Also, an example, if you were given something like this, 1, 2, 3, 8, 9, and there was a dot, dot, dot at the end that shows that it is non-terminating, and there's also no pattern present there, that makes that an irrational number. And not a perfect square would be something like the square root of 6. If you type that into your calculator, you get a decimal that continues, rather than a simplified rational number when we have a perfect square like we did over here, the square root of 25 or the square root of 16. So a quick numbers overview. You have your real numbers, which is everything that we've been talking about so far. In that subset of real numbers, we have rational numbers, and then down over here, these are going to be our irrational numbers that are not rational. Inside rational numbers, we have integers. Those are the whole numbers and their opposites. So numbers like -3 and 3, or -10 and 10, those are all integers. And natural numbers are the counting numbers. So when we start at 1, 2, 3, and we go on for infinity, those are our natural numbers. And then down here, we just have a little note that our whole numbers are the natural numbers, but they include 0 as well. So that's really the only difference between natural and whole. In our first example, we're going to take this list of numbers and we're going to classify each of them as either being irrational or rational, and we're also going to include a reason why we think that's the case. So the number 7, that is rational, and I would just say because it can be written as a fraction. Nine over 7, that's also going to be rational. It is a fraction made up of rational numbers, so it is rational. The third example, 0.575. Notice how this ends, it terminates, so that makes that a rational number, the terminating decimal. Okay, the square root of 11. 11 is a prime number. It is not a perfect square, so this is going to be an irrational number. In our fifth example, we have 2.32547 dot dot dot. This dot 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 at the end tells me that this is going to continue. Okay, so it is non-terminating, making it irrational. And then lastly, we have 2 plus the square root of 17. Since the square root of 17 is irrational because it's not a perfect square, when I add 2 to it, it's still going to be an irrational number because that decimal part is just going to continue and continue. So it's not a perfect square. All right, so this next example, this would be a great time for you to pause, try these on your own, and then come back to check your work. So the first one, the number 126, that's a great rational number. Any integer, whole number, those are all rational numbers. So I could even say like all integers are rational. And really the reason it is because they can be written as a fraction. The square root of 49, that's going to be a rational number because this is a perfect square. Square root of 49 just equals 7. 0.125, that's also going to be rational because this is a terminating decimal. It has an end. Next example, 4 pi. Anything that has a pi with it is always going to be irrational. So pi is always irrational. Next example, 1.292929 dot dot dot. Again, we have that dot dot dot. It's irrational because it is non-terminating. And then 2 times the square root of 3, the square root of 3, that is irrational because it is a non-perfect square. Or not a perfect square. Not perfect square. All right, so hopefully these examples help solidify the difference there between rational and irrational. If you need more information on this topic, you can check out the Learning Target spreadsheet for additional resources, videos, and practice.